Hello and welcome to the Sleepy Atom. Tonight we're setting sail not on the sea, but into space. Not just anywhere, but toward the one place in the universe where time forgets how to move, and space forgets how to behave. The black hole. Now that might sound a bit dramatic, and yet the black hole is real. So real in fact that there may be one gently tugging at the stars above your head right now, invisible, quiet, watching. But don't worry, we're not here to fear it. We're here to float toward it slowly, as if we were weightless dust drifting softly through the void, curious but calm. What would happen if you fell into a black hole? Would it be sudden? Would it hurt? Or would you notice nothing at all? This video isn't a crash course, it's a story, a slow-motion descent, and you won't need to remember any numbers or draw any diagrams. All you need is your breath, your imagination, and a little willingness to wonder. So let's float together through the cold, quiet corridors of the cosmos and begin at the only place we can begin, with a question, the edge of curiosity. Most people don't lie awake at night thinking about gravity, but when they do, they often end up here. Black holes are like cosmic riddles dressed in shadow, the kind of mystery that pulls at the edges of your mind when the lights are out and the world has gone quiet. You don't need to be a scientist to wonder what's out there. You only need to be human. Imagine standing at the edge of the observable universe. No noise, no motion, just the gentle hum of emptiness. And then, out of that silence, something strange. A place where gravity is so strong, even light cannot escape. A black hole doesn't shine, but it has a presence, like a quiet breath behind a curtain. It doesn't announce itself, but everything nearby knows it's there. We've never seen one directly with our eyes, yet somehow black holes have become icons of science. They appear in films, dreams, and distant fears, but in truth, they're not monsters. They're simply nature's way of reminding us how little we know. They're a whisper from the universe that says, "Look deeper." So we do, with telescopes and mathematics, with stories and soft questions. And with those questions, we begin to approach the edge of curiosity, the edge where falling becomes learning and fear becomes fascination. It's not about reaching the answers. The black hole doesn't promise closure. It only promises transformation. Once you go close enough, you're changed. Not just in space, but in thought. That's the quiet power of curiosity. It bends you slowly, gently, toward a new shape, one made of wonder. What is a black hole, really? Forget the dramatic movie scenes with swirling chaos and screaming stars. At its core, a black hole is a very simple idea. So much mass packed into so little space that gravity can't help but go wild. It's not what's inside a black hole that matters most at first. It's what it does to everything else around it. To picture it, take something familiar, like Earth, and start shrinking it. Smaller and smaller until it's the size of a marble. The gravity would still pull just like before, but now the surface would be impossibly steep. If you tossed a pebble upward, it wouldn't come back. Even light would try to escape and fail. That's all a black hole really is. Gravity without a pause button, a collapsed star, or perhaps a swollen relic from the early universe. It doesn't suck things in like a vacuum cleaner. It just bends space in a way that makes leaving nearly impossible. The real trick, though, is space-time. Einstein taught us that gravity isn't really a force, it's the shape of the stage. A heavy object curves the floor beneath it, and other things roll toward it. A black hole? That's where the floor folds so steeply, it becomes a well without a bottom. We'll go deeper into that later. But for now, just remember this. A black hole isn't the end. It's a beginning. of a different way of thinking about everything: space, time, mass, and light, all tangled in a slow dance that never quite ends, the point of no return. There's a moment in every fall where turning back becomes impossible. In a black hole, that moment is marked by an invisible boundary, the event horizon. It doesn't glow, it doesn't ripple, it just is. A cosmic doorway with no exit sign. Cross it, and the rules of space-time begin to change. The event horizon isn't a wall. You wouldn't feel a bump as you passed through it. No alarms, no warning, just silence, and a soft erasing of your ability to leave. To an outside observer, it would seem like you froze. You'd fall slower and slower, your light stretching into red, then disappearing. But from your point of view, you keep falling, normally, until normal begins to shift beneath your feet. The event horizon is the last place where space and time behave like old friends. Beyond that line, time becomes space, and space becomes time. You don't just move forward, you're pulled downward in a way that's more than direction. It's fate. There's a kind of beauty in that, a moment where motion becomes destiny, where physics bows its head and says, from here on, you're on your own. And in that solitude, the black hole begins to reveal its true nature. Space-time, like a soft blanket. Let's change the metaphor for a second. Don't think of gravity as a tug of war. Think of it as a blanket, soft, heavy, stretched across the universe. Every planet, every star, every piece of mass presses gently into that blanket, making dips, slopes, and curves. Now imagine placing something enormous on that fabric, something heavier than your mind can hold. A collapsed star, squeezed into a single point. That blanket would stretch, bend, then tear. And that tear? That's your black hole. But here's the strange part. The blanket isn't just space. It's space and time woven together. When something bends space, it also bends time. And near a black hole, time slows, not metaphorically, but physically. Clocks tick differently. Moments stretch like warm taffy in cold hands. The closer you get to the black hole, the more dramatic the slope. You're not just falling, you're sliding into a well of time. And that well doesn't end with a thud. It keeps going, folding in on itself, deeper and deeper, as if the fabric has forgotten how to lie flat. We often think of space as empty and time as straight, but black holes remind us neither is quite what we imagined. The universe is softer, stranger, and far more curved than we thought. What would you see on the way in? If you ever did fall toward a black hole, your last view of the universe might be the most beautiful thing you've ever seen, because light doesn't behave the way we expect near that kind of gravity. It bends, loops, and dances. Stars above you would seem to gather around the black hole's edges, distorted into a glowing ring called the photon sphere. You'd see the back of your own head, light looping around and returning from behind you, a cosmic mirror with no silver. Colours would shift. As light struggled to escape, it would stretch from visible to red to infrared to invisible. Things that once shone brightly would fade like memories in the fog. It wouldn't happen fast, just gradually, dreamily, as if the universe were slowly closing its eyes. And then there's the eerie stillness. As your speed increases, your sense of time stretches. You might feel like you're falling forever, but forever might last just a moment, or many lifetimes, depending on who's watching. Falling into a black hole wouldn't be chaos. It would be quiet, maybe even peaceful. A front row seat to the most surreal light show in the cosmos. And as we open more of this story ahead in the video, we'll gently float past that final edge and begin to ask what lies beyond it. Stretching time itself. Time, up here on the surface, feels like a constant rhythm, a tick, a tock, a slow walk across the hours. But near a black hole, time doesn't walk. It begins to kneel, and eventually, it lies completely still. This isn't poetry, it's physics. The stronger gravity becomes, the more it bends the path of time. And black holes, they bend it so severely that to someone far away, it looks like you're frozen in place forever, just hovering near the edge, never falling in. But for you, the one falling, nothing feels stuck. You keep moving. The minutes keep passing. But if you looked up, the universe would be speeding away. Galaxies would blur. Stars would accelerate. The future would rush past you like a silent breeze you can't stop. It's like standing still in a train station while the world ages outside. Civilizations rise and fall while you take one slow breath. In the deepest gravity wells, time is a whisper, drawn out, thinned and strange. And all of it, the slowness, the stretch, the quiet warping, is just another way the black hole wraps its arms around you, not to harm you, but to teach you what time really is. A shape, a feeling, a silence, gravitational lensing, a halo around nothing. One of the strangest sights near a black hole isn't what disappears, it's what reappears. Light, the fastest traveler in the universe, doesn't always fly straight. When it passes a black hole, it bends, not just a little but dramatically, like water around a rock. This bending is called gravitational lensing, and it means you could look at a black hole and see a perfect circle of light around it. The distorted glow of stars and galaxies that lie behind it, smeared into a ghostly ring. A halo around the invisible. What's even stranger is this. Some of that light is taking the long way around. It might circle the black hole once or twice, before finally reaching your eyes. You're not just seeing space. You're seeing a history of space wrapped around darkness. Photons, little packets of light, don't obey straight lines near a black hole. They swirl, they curve, they orbit. And if they get too close, they fall in, never to return. What you're left with is this eerie, glowing echo of what once was. So the black hole, though dark, paints with light. It doesn't shine, but it creates a masterpiece with the light around it. And somehow, it always knows just how much to reveal and how much to hide. The strange silence of the vacuum. If you were drifting toward a black hole, you might expect noise, crashes, roars, perhaps even the thunder of collapsing stars. But that's the thing. Space doesn't speak. And black holes? They are the masters of silence. There is no air between you and the stars, no wind to carry a scream. The deeper you go, the quieter it becomes, until even your thoughts begin to feel muffled, as if the void itself is pressing a finger gently to your lips. The silence isn't empty, though. It has weight. It has texture. You begin to notice the hum of your own body, the pulse in your ears, the quiet rustling of memory. In the vacuum, nothing touches you, but you begin to feel everything. And yet beyond that hush, there's power. Gravity doesn't need noise to work. Light doesn't need words to bend. The black hole doesn't announce its presence. It just waits. And in that stillness, you begin to sense the truth of it all. Silence is not the absence of sound. It is the presence of space itself. Vast, endless, stretched out across time, folding in slowly, inviting you to listen not with your ears, but with your soul. If you dropped a clock in, let's try something simple. Imagine holding a small clock in your hand and letting it go. It begins to fall toward the black hole. What happens next will change your entire understanding of time. To someone watching from far away, the clock seems to slow down. Its ticks become distant, its hands sluggish. and right before it reaches the event horizon, it appears to stop, frozen, caught in mid-fall, never quite touching the edge. But you, the one who dropped it, know better. You see the clock continuing, falling further, ticking normally in your frame of reference. The black hole doesn't actually stop time, it just changes how it's seen. This is time dilation in motion, and it gets even weirder when you realize that the deeper something falls, the less information comes back. The light from the clock grows redder, dimmer, until it vanishes completely, not because it's destroyed, but because its light can no longer climb out. So a simple clock becomes a storyteller. It reveals how gravity stretches time and how black holes play with perception. What seems frozen is falling, what seems still is moving, and what seems gone may simply be hidden. The calm before the fall. There's a moment, just before you reach the event horizon, when everything is strangely peaceful. The stars still twinkle behind you. Your body feels weightless. And though you're falling faster than light could escape, it doesn't feel like falling at all. That's the illusion of free fall. Near a black hole, you're not being pulled like a rope is tugged. You're sliding, gently, naturally, along the curves of space-time. It's not a fight, it's a surrender. Your instruments might go haywire, your clock would slow, your vision might warp slightly around the edges. But inside your body, calm, no stretching yet, no burning, just the surreal sense that something very big is about to change. This moment is special because it's the last time anything feels familiar. After this, space and time will twist into something new. But right here, just outside the boundary, you're still you, still thinking, still breathing, still choosing to look ahead. The calm before the fall isn't a warning, it's a gift, a moment of stillness before the dive, a deep breath before the curtain rises. And ahead in this video, we will cross that curtain and step silently across the edge into a place where light cannot return, inside the event horizon. And now, we've crossed it, quietly, without a sound. No flash, no shift, no alarm. Just a soft, invisible line past, and everything begins to feel a little less certain. From this point forward, all paths point inward, not because you want to go there, but because space-time no longer gives you a choice. The very geometry of the universe has tilted. No matter which direction you move, even if you try to turn around, all roads lead deeper. That's the first strange thing. In here, space flows like a river, and you're not swimming through it, you are part of it. Even light, the fastest traveller in the cosmos, can't paddle upstream anymore. It tries, and it fails. The current is too strong, but strangely, from your perspective, things still feel normal. You're floating, drifting, thinking. Your body doesn't stretch, not yet. Your thoughts aren't in panic. Instead, a deep and eerie calm takes hold. Because here, physics is no longer fighting you. It has let you in. We don't know exactly what lies beyond this line. No one has seen it. No message has returned. And that, more than anything, is what makes this place so hauntingly beautiful. It's not destruction you've entered. It's the unknown. Spaghettification. But not quite. Now, about that word, spaghettification. It sounds like a silly invention, but it's very real. In extreme cases like small black holes, the difference in gravity between your head and your toes becomes so sharp you begin to stretch, slowly, then dramatically. But let's soften that image for a moment. Not all black holes are that violent. In fact, if you fell into a supermassive black hole, the kind that sits at the heart of a galaxy, the tidal forces would be gentle at the horizon. You might not feel anything at all. It's only much deeper in, closer to the singularity, that things begin to pull. Not just your body, but your sense of direction, of shape, of time itself. Everything starts to lengthen in one direction and squeeze in the others. Gravity isn't crushing you, it's reshaping you. It's a kind of stretching that isn't painful in the way we imagine. There's no blood or scream, just distortion, quiet, relentless, final, like pulling taffy in slow motion across dimensions you no longer understand. So yes, spaghettification is a funny word, but inside the black hole, humor and horror coexist, and every step you take closer to the center is a soft surrender to forces that no human has ever survived to describe. Would you notice crossing over? You'd think there would be a line, a sound, a feeling, something to mark the exact moment you passed into the black hole. But the strangest truth is, you wouldn't notice a thing. That's because the event horizon isn't a physical surface. It's a boundary drawn in math, not in stone. To you, falling freely through space, everything feels the same. No pressure spike, no jolt, just continuous motion through curved space. But to someone watching you from far away, it's the opposite. They see you freeze at the edge, hover, fade into red, and eventually disappear entirely. It's not that you've stopped, it's that time itself has wrapped you in silence. This creates a haunting disconnect. You are moving, but unreachable, alive, but lost. You and the outside world no longer share the same definition of now. Their clock has raced ahead. Yours has slowed to a whisper. And perhaps that's the most profound part of this journey, that crossing into a black hole doesn't feel like a violent break, but a subtle separation. Not from life, but from being seen. A gentle unthreading of your connection to everywhere else. Falling faster than light, yet feeling still. Inside the black hole, your speed increases, not just faster than sound or rockets, but faster than light could ever escape. Yet oddly, you feel still, like you're floating gently through a thick dream. How can you be moving faster than light and feel so calm? Because inside the event horizon, the rules twist. You're no longer falling through space. You are space in motion. The direction of time has shifted. It points inward, not forward. You might pass through layers of intense curvature, but your body doesn't scream. Your brain doesn't panic. Physics isn't tearing you apart yet. It's just bending your expectations. You thought falling would feel frantic, but it's slow, like being rocked in the arms of gravity itself. To the outside world, this moment is untouchable. They'll never know what you're feeling. No message, no light, no whisper escapes to carry back the story. But inside, there's clarity, a strange serenity, the kind you only get when all other choices fall away. So yes, you're moving faster than light could flee. But you feel like you're at rest, a deep, echoing rest, one that may last forever, or no time at all. The world watching you freeze. Imagine someone watching you fall into the black hole. Maybe it's a friend, a scientist, someone who doesn't want to lose you. To them you begin to slow. Your shape stretches, your glow fades, but you never quite vanish. You freeze, forever at the edge. That's not a trick. That's time dilation, playing out in real time. The closer you get to the event horizon, the more your clock ticks differently. To you, everything is flowing normally. But to them, you're drifting into eternity. They might wait hours, years, centuries, and still see the faint shimmer of your final moment. You, locked in pause. A ghost trapped on the edge of gravity's deepest well. It's heartbreaking and poetic. Eventually your image fades. Not because you moved, but because the light that once carried you has been stretched into invisibility. It's no longer red. It's beyond red. Infrared, microwave, radio, and then nothing at all. You're gone now. But to them, your last light still lingers, a moment smeared across the sky, preserved in memory, though never truly retrievable. And ahead in this journey, we'll begin to follow you deeper, beyond their eyes, beyond their clocks, into the realm that no one's ever come back from. Black hole colours, not just black. You might be surprised to hear this, but black holes aren't completely black, not in the way we imagine pitch darkness. They're surrounded by some of the most energetic, glowing, chaotic light shows in the universe. That's because matter falling into a black hole doesn't just disappear quietly. It screams. It heats up. It spins faster and faster, forming a bright, swirling disk called an accretion disk, a glowing ring of plasma spiraling toward oblivion. These disks can shine with X-rays, gamma rays, and ultraviolet light. The heat is unimaginable, millions of degrees. And yet to the eye, they might look like a shimmering ring of white-blue fire wrapped around a perfect shadow. The contrast is beautiful. A black hole doesn't shine, but its edges radiate energy. Particles dance near the speed of light. Magnetic fields twist into violent shapes. And some black holes even eject giant jets of energy, beams stretching thousands of light years across space. So no, black holes are not empty voids. They are framed by colour, carved in contrast, and painted with invisible flames. The darkness in the middle is only part of the picture. The rest is a silent storm of light. The geometry of nowhere. We like to think of space as a flat grid, a simple backdrop with distance and direction, but near a black hole, that grid bends, warps, loops in on itself until forward becomes downward and direction becomes destiny. This isn't metaphor, this is geometry, but not the kind you learned in school. This is curved geometry, where triangles don't add up and straight lines come back to where they started. It's a place where here and there lose their meaning. Inside the black hole, space folds inward so completely that every possible path leads deeper in. You could turn, twist, even try to fly outward. And still, the geometry pulls you toward the center, not by force, but by shape. It's like walking across the surface of a funnel, only to find that every step you take still leads downward. There's no edge to grip, no wall to climb. The structure itself has become a trap, elegant, quiet, and complete. This is why we say the black hole doesn't just trap matter, it traps geometry. It rewrites the shape of everything it touches. And at its heart, that shape collapses into something we still don't understand. The shape of falling. Falling into a black hole isn't a straight drop. It's more like a spiral. A long curving descent that starts gently, then tightens, narrows, and vanishes into a single invisible point. You don't tumble. You swirl. This spiral path is part of what's called geodesic motion. It's the natural way objects move when space is curved. And near a black hole, the curves become so steep, they pull everything inward in elegant, slow arcs. Even light follows this spiral. It loops, it dances. Sometimes it escapes, sometimes it doesn't. The closer you are, the tighter your path, until eventually there's no turning back. You're riding the curvature now, drifting deeper, softer, faster. Imagine what that looks like from your perspective. Stars twist into rings. The universe warps around you like a kaleidoscope of stretched time. You are still falling, yes, but it feels like floating through a funnel of mirrors. And somewhere in that spiral, the idea of up or out disappears. There's only motion, only descent, only the soft, patient pull of gravity guiding you toward the center of everything, or maybe the center of nothing at all. Could you send a message back? Let's say you brought a radio, or a flashlight, or even a whisper? Could you send a message back from inside the black hole? The short answer is no, but the long answer is quietly beautiful. From the moment you cross the event horizon, escape becomes impossible. Not because you're trapped by walls, but because the fabric of space itself no longer points outward. Light itself curves inward now. Any signal you try to send follows the same path. You could shout, you could flash your light, but those waves would never reach the outside. They'd spiral inward, pulled by the same gravity you are. The information you carry, your voice, your data, your heartbeat, would remain hidden. To someone watching, your last message might reach them just before you vanish. And then, silence. Not because you've gone quiet, but because your light can no longer make the journey. You're still speaking, but across a bridge that's been erased. And perhaps that's the hardest truth about black holes. Not that they destroy, but that they isolate. A place where communication itself breaks down, not violently, just quietly, softly, irretrievably, like a letter caught in an endless fold, a whisper from the singularity. At the very center of a black hole lies something we call the singularity. It's not a place exactly. It's not a point you can touch. It's a region, or perhaps a moment, where the math breaks down. Here, density becomes infinite. Space-time curves without end. The rules of physics that work so well everywhere else no longer hold. Even time, as we understand it, might stop flowing in a meaningful way. It's a whisper from the edge of understanding. Some scientists believe the singularity is a real place. Others say it's just a placeholder, a gap in our knowledge, a question mark painted in gravity. But one thing is certain, nothing ever comes back from there. If you were to reach it, slowly, gently, completely, you wouldn't explode. You wouldn't even scream. You would simply cease to be part of the universe as we know it, folded into the equations, erased from the map. And yet, the singularity isn't terrifying. It's humbling. It tells us that we don't know everything, that our universe still holds secrets, and that at the very center of every great collapse, there may be a doorway we've never opened. Singularity, a word for mystery. The word singularity sounds scientific, but in truth it's a confession. It means we don't know what's here. It's the place where all our formulas, beautiful, elegant, reliable, suddenly fall silent. At the center of a black hole, all the mass is thought to collapse into a single point, not a point you could touch or see, but something infinitely small and infinitely dense, a place where space has no size and time may have no direction. What does that mean? No one really knows. It might be the very end of space-time, or just a transition to something else. But one thing is clear. At the singularity, our laws of physics no longer work, not because they're wrong, but because they've reached their limit. It's like asking what's beyond the edge of a map that was never drawn. You can imagine it. You can even dream about it. But the moment you arrive, the compass spins and the stars forget their names. And maybe that's okay. Maybe the singularity exists not just to challenge science, but to remind us that mystery is still allowed to exist, that even in a universe of equations, there is room for awe, quantum foam beneath reality. When we think of space, we imagine stillness, a blank black void, silent and smooth. But zoom in close, closer than atoms, closer than particles, and space itself begins to shimmer. This is the realm of quantum foam, a name that sounds soft, even playful, and yet it describes one of the most chaotic, mysterious places in physics. At the tiniest scale, space isn't flat. It bubbles. Particles pop in and out of existence. energy flickers like fireflies. It's not emptiness, it's a constant dance of uncertainty, the building blocks of existence, rearranging themselves in ways we still can't predict. Now imagine putting a black hole into that bubbling fabric, a region of infinite density, inside a fabric that can't stay still. It's like dropping an anchor into a stormy ocean made of probability itself. Some physicists believe this is where the true secrets lie, that deep inside black holes, or just outside their edge, quantum foam might hold the key to unifying everything: gravity, time, matter, even consciousness. A strange hope wrapped in flickers and fuzz. What does the singularity feel like? We'll never touch a singularity, but that doesn't mean we can't try to imagine it, not with numbers or equations, but with feeling, with intuition, with the soft curiosity that whispers just before sleep. Imagine standing in a place where distance has collapsed, where every direction folds inward, and where time no longer has a rhythm. Not silence, not noise, just stillness, absolute and untouchable. You might not feel pain, or fear, or motion. You might not even feel you. At the singularity, identity could melt like snow under starlight. Thoughts, shapes, memory, all unraveling, slowly, quietly, into pure presence. It would be like falling into the center of a dream without edges, without color, without ending. Not because you've vanished, but because the structure that held your experience has been set down. Maybe it feels like peace. Maybe it feels like return. Or maybe it's beyond all language, a place no words were ever meant to reach. We can't say for sure, but in its unknowability, the singularity becomes one of the most poetic places in the universe. Can anything escape from here? They say not even light can escape a black hole. And it's true. Once it crosses the event horizon, the slope of space becomes too steep. The paths that once led outward now lead only in. But there's a debate, one of the great puzzles in modern science. Is information destroyed inside a black hole? If you toss in a book, or a person, or a planet, is that story gone forever? According to quantum mechanics, information shouldn't be lost, but general relativity seems to say otherwise. And so we have the black hole information paradox, a quiet tug-of-war between two of physics' most trusted theories. Some believe that information is somehow stored in the event horizon itself, like a cosmic hard drive. Others think it leaks out slowly through a process called Hawking radiation. Photons escaping, pixel by pixel, encoding something forgotten. And then there are those who suggest the universe has backup plans we've never imagined. Holograms, firewalls, multiverse bridges, all quiet possibilities, quietly waiting. Whether or not information escapes, the black hole keeps us asking, and in that way, it may be the greatest teacher of all, the firewall paradox. Now here's a truly strange idea, one that splits scientists right down the middle. What if the inside of a black hole isn't smooth and quiet, but burning hot at the edge? What if crossing the event horizon feels more like touching fire? This is the firewall paradox. According to some theories, if information isn't allowed to be lost, then the event horizon must be doing something dramatic. It might not be a soft veil, but a sharp wall of heat, a place where everything is violently erased. But wait. Earlier we said you'd feel nothing when falling in. So which is it? Gentle or violent? Smooth or fiery? That's the paradox. Both ideas come from respected theories, but they can't both be true. If the firewall exists, then something big is broken in our understanding of space-time. If it doesn't, then information might truly be lost. Either way, the black hole is forcing physics to choose between its own rules. For now, we don't know the answer. No one does. But the idea of a firewall reminds us, Even quiet things may be hiding storms, and sometimes the edge of knowledge glows hottest right before it breaks. Your journey to the center of time. Most places we visit have a direction: north, east, upward, backward. But inside a black hole, those labels start to break. The only direction that matters now is forward. And forward doesn't mean out. It means toward the center of time itself. That's because inside the event horizon, time and space quietly switch roles. Time points inward. It's not something you travel through. It's something that brings you closer to the singularity, step by invisible step. You can move left or right, twist, turn, or spin. But no matter what you do, you keep drifting deeper into the future. And that future is the heart of the black hole. It's not a place you fall into. It's a moment you are pulled toward. So your journey to the singularity becomes a journey through time, not just space. You're not just sinking into gravity, you're flowing into tomorrow, or something that comes after tomorrow, or something beyond time itself. That's one of the most humbling ideas in physics, that sometimes the future isn't ahead of us in space, it's beneath us in gravity, and we're all falling toward it, slowly, just not as fast as those who fall past the horizon. The inside is bigger than the outside. Here's a twist you may not expect. The inside of a black hole might be bigger than the outside. Not in some obvious stretch your arms out kind of way, but in how space is measured when it bends. Think of it like this. Take a balloon. To the eye, it's small, but the surface area, as you inflate it, grows and grows. Now imagine a space that's folding inward on itself, not inflating outward, but curving into extra dimensions. Some physicists suggest that the volume inside a black hole could be vast, far bigger than the opening suggests, a kind of pocket universe curled inward with more space inside than the region it came from. This idea bends our minds. It challenges our intuition, because we're used to thinking that bigger things look big. But near a black hole, appearances lie. You could fall into something that looks small and find yourself surrounded by endless interior space. It's like a room with no walls, a hallway with no end, a reality that grows the deeper you fall. And in that space, there may be room, not just for you, but for entirely new ideas about how the universe holds its secrets. Maybe it's a portal. Now we step softly into speculation, into the poetry of possibility, because some scientists, including Einstein himself, once imagined that black holes might be portals. Not just prisons, the idea is called a wormhole, a tunnel connecting distant parts of space, or even different universes. At one end you have a black hole, at the other, maybe a white hole, a place where matter comes out instead of falling in. So what if falling into a black hole isn't the end? What if it's a bridge? Not a bridge you can steer through, but a one-way drift through compressed space and distorted time to somewhere else entirely. Wormholes, if they exist, would be fragile, unstable. They might collapse before anything could pass. But still, the math doesn't completely rule them out. In the equations they whisper, what if? And maybe that's the magic of this chapter in our journey. Not proof, not certainty, but wonder. The idea that black holes might not just erase, but transport, and that the edge of one world might open quietly into the birth of another. Black holes and baby universes. Go one step further. What if, instead of ending in a singularity, a black hole becomes something new? Not just a tunnel, but a seed, a spark, a baby universe, budding from the collapse of a dying star. It sounds wild, but some cosmologists believe it's possible. The conditions inside a black hole, infinite density, extreme energy, rapid inflation, might mirror the early universe. In fact, the Big Bang itself may have looked eerily similar to the singularity at the center of a black hole. So maybe, just maybe, each black hole isn't just absorbing matter, it's planting it, folding it inward until it bursts into expansion, not here, not in our space, but in another universe entirely. From this view, black holes aren't dead ends, they're cosmic wombs, each one a quiet passage to a newborn cosmos. Our universe may have started this way, and maybe, in some distant corner of time, another universe is forming right now, inside a black hole we'll never see again. It's not science fiction, it's scientific poetry, written in math, whispered through gravity, still incomplete, but breathtaking in its implications. Echoes in the darkness. Even though nothing escapes a black hole, they're not completely silent. They leave echoes, ripples, faint messages in the fabric of space, called gravitational waves. These waves are like tiny shudders in reality itself. They stretch and squeeze space as they move, like ripples across a pond. Except the pond is the universe, and the pebble is two black holes colliding in the dark. When these massive objects spiral into each other and merge, they send out a blast, not of light, but of gravity. And after travelling across the cosmos for billions of years, those waves reach us. Faint, but unmistakable. We've detected them, not with microphones or telescopes, but with the most delicate instruments on Earth, lasers and mirrors so precise they can catch the quiet tremble of space from galaxies away. These echoes are the black hole's final song, a vibration not of destruction, but of movement, of merging, of memory. And in those ripples is the proof that black holes are not silent tombs. They're drummers, storytellers, dancers in the darkness, sending signals we're only just learning to hear. A symphony without sound. Black holes don't hum like violins or howl like wolves, yet scientists describe them as part of a grand cosmic symphony, a song played not in air but in space-time itself. When two black holes spiral toward each other, they form a binary dance, slowly spinning, drawing close, faster and faster, until the moment of union sends out a burst of gravitational waves, a note, a tremor, a whisper in the fabric of existence. These waves aren't just random noise. They carry a rhythm, a frequency, a tone. Scientists can listen to them using special instruments like LIGO, and what they hear is hauntingly beautiful. A faint chirp, a quick rise in pitch, and then silence. It's not sound in the traditional sense. You couldn't hear it with ears, but you can translate it into audible tones, and what emerges is a brief, eerie song from the darkness, a sound that began 1 billion years ago and finally reached Earth as you tucked yourself into bed. So even in silence, black holes compose music, not for applause, not for attention, but because motion itself is a melody, and gravity, when it moves, cannot help but sing. The shadow of the invisible. You might remember the photo, a soft glowing orange ring surrounding a perfect black circle, the very first image of a black hole's shadow, not a painting, not a simulation, but a glimpse, a real one, into the mouth of the unknown. Captured in 2019 by the Event Horizon Telescope, that image showed us the black hole at the centre of galaxy M87. It was 55 million light-years away, and larger than our entire solar system. And yet, it left a shadow we could see. But here's what's strange. We didn't capture the black hole itself. We captured the light trying to escape, the plasma circling the event horizon, the silhouette it carved against the chaos. It was like photographing the outline of a hole by watching how fireflies danced around it. That shadow wasn't just a visual, it was confirmation, proof that the math works, that Einstein's predictions were right, that something truly unfathomable lies at the heart of galaxies, shaping stars and bending time. So the shadow of the invisible became a lighthouse, a silent signature of a force too powerful to reflect light, but too elegant to remain unseen forever. Galaxies built on darkness. Here's something cosmic to think about as you rest. Every massive galaxy, including our own Milky Way, has a supermassive black hole at its center. It's not an accident. It's a pattern, a rule written into the architecture of the universe. These central black holes can be millions or even billions of times the mass of our Sun. And they don't just sit there quietly. They shape the galaxy around them, pulling stars into orbits, guiding the formation of spiral arms, influencing the fate of matter across hundreds of thousands of light years. Some even power quasars, the brightest objects in the universe, blazing with more energy than entire galaxies, all from material spiraling into the black hole's embrace. From a distance, they look like stars. But up close, they are galaxies set on fire by gravity. Without these dark anchors, galaxies might fly apart, stars would drift, chaos would reign. But with them, there is structure, order, dance, balance in the swirl of starlight. So maybe darkness isn't the absence of creation. Maybe it's its foundation. Maybe the universe builds its most luminous homes around the quiet gravity of the unseen, feeding the giant. Black holes are often imagined as always hungry, devouring stars and dust without end. But in truth, most of them are patient, quiet, empty even. They can go years, centuries, millennia, without feeding at all. But when a star drifts too close or a cloud of gas falls inward, the feast begins. Material forms a glowing disk. Friction heats it to unbelievable temperatures. Radiation pours out across space. It's one of the brightest shows in the cosmos. And then, like a candle flickering out, the brightness fades. The meal is over. The black hole has absorbed its fill and returns to stillness, waiting, always waiting, not hunting, not chasing, just being. Some black holes feed on one star for centuries, others devour entire star clusters in a burst, and others remain silent forever, surrounded by emptiness, with nothing to eat and no light to give off, invisible, undetectable, alone. And yet they remain, eternal centers of gravity, guardians of motion, watching silently until the universe drifts another offering across their path. Are we orbiting one right now? Here's a thought to cradle you as you drift into sleep. Right now, you, the Earth, our Sun, and everything we know is quietly orbiting a black hole. It's called Sagittarius A's. It sits at the very center of our galaxy, about 26,000 light years away. It's massive, 4 million times heavier than our Sun. And yet, we don't feel its pull directly. It's too far, too gentle, but it's there. Every 250 million years, our entire solar system completes one grand orbit around it, like a cosmic merry-go-round moving through an invisible carousel. And as we orbit, we carry on with life, completely unaware of the great gravity shaping our path. We can't see Sagittarius A star with our eyes, but with telescopes, we've watched stars whip around it at unbelievable speeds, as if chasing ghosts. And from that motion we know something enormous is hiding there. So yes, we live in a galaxy built on a black hole, and our journey through space is part of its orbit. We're not falling in, just circling gently. One slow, graceful loop through the dark heart of the Milky Way. Not all black holes are big. When we think of black holes, we often imagine giants, cosmic monsters swallowing suns. But not all black holes are massive. Some are small, some are ancient, some may be floating quietly through space, unnoticed. The smallest ones we've discovered come from the collapse of massive stars, a few times the mass of the Sun, compressed into a region no bigger than a city. These are called stellar mass black holes, and they're surprisingly common. Astronomers believe there may be hundreds of millions of these in our galaxy alone, but most are invisible, hidden in the dark. They don't glow, they don't shout, they wait. Silent until a nearby star gives them something to feed on. And then there are theories, still unconfirmed, that even smaller black holes might have formed in the early universe. Tiny relics born seconds after the Big Bang, some no larger than a mountain or even a grain of sand, yet with gravity strong enough to warp space. We haven't found those primordial black holes yet, but if they exist, they could tell us things about the universe we've never even imagined. Because sometimes, the smallest holes lead to the biggest mysteries. The possibility of mini black holes on Earth. Now let's venture into a strange but thrilling idea. Could a black hole ever form? Here on Earth? Don't worry, there's no danger in this story, but the thought experiment itself is worth dreaming about. Some scientists have wondered if we smash particles together hard enough, say inside the Large Hadron Collider, could we create a tiny black hole? Not one that swallows cities, but one so small it evaporates almost instantly. The theory suggests that if extra dimensions exist, hidden folds in space we can't yet see, the energy threshold for forming a microscopic black hole might be lower than we think. Just enough perhaps for a particle accelerator to momentarily form one. But here's the comforting part. Even if we could make one, it would vanish in a fraction of a second through Hawking radiation. A little flash, a whisper of gravity, and then gone. So far, no black holes have been detected at particle colliders, but the idea still lingers, because even the smallest window into this phenomenon could open the door to new physics, and that alone is a reason to keep searching. The Great Escape. Stephen Hawking changed the way we think about black holes, not by falling into one, but by imagining one slowly fading away. A thought so bold, it shifted the foundation of physics. Before Hawking, we believed nothing could escape a black hole, but quantum theory suggested otherwise. At the edge of the event horizon, tiny pairs of particles constantly pop into existence. Usually they annihilate instantly, but sometimes one falls in and the other escapes. This escapee carries away a tiny amount of energy. Over time, eons really, these small losses add up. The black hole shrinks, its temperature rises, and eventually it evaporates entirely, leaving behind nothing but radiation and memory. This process is now called Hawking radiation. It's still theoretical, we haven't seen it yet, but the math holds. And if it's true, it means black holes aren't eternal. Even the biggest ones will fade. It's a humbling idea that even the most powerful objects in the cosmos have lifespans, that even darkness has an end, and in that slow surrender, there's a quiet kind of grace. Can black holes die? The word immortal often comes to mind with black holes, but if Hawking was right, then even these cosmic titans have an ending. It's just unfathomably slow. A stellar mass black hole might take 10 to the 67th years to evaporate. That's a number so big our brains can't hold it. A supermassive black hole? It could take 10 to the 100th years or more. Longer than stars, galaxies, even atoms will last. As they shrink, they get hotter, brighter, more unstable, until the final moment when the black hole explodes in a burst of radiation, a farewell, a tiny firework, at the end of time. This would happen long after everything else in the universe has gone quiet. No stars, no light, just the final black holes flickering out one by one, the last embers of creation. And then, silence. a universe without heat, without motion, a deep, frozen calm. Whether that's truly the end or a doorway to something else, we still don't know. But in the death of black holes, we glimpse the final heartbeat of the cosmos, the memory of light. Even after a black hole vanishes, something might remain, not matter, not form, but memory, a trace, an imprint in the very structure of space. Some physicists believe that when light falls into a black hole, it leaves behind a mark, subtle distortions in the event horizon, encoded information, a history carved in gravity. If Hawking radiation carries information away slowly over time, then perhaps black holes don't erase stories. They just whisper them back to the universe, piece by piece, pixel by pixel, over eons. It's like watching a painting being restored, one fleck at a time, or hearing a song played in reverse, and realizing the lyrics are still hidden in the echoes. This idea that black holes preserve the memory of what falls into them could resolve one of the greatest paradoxes in physics. And more than that, it speaks to something beautiful, that maybe nothing is ever truly lost. Not you, not the stars, not the light that once touched your face. The universe, in its own strange way, remembers. The black hole in our backyard. It's easy to think of black holes as distant creatures, but they're closer than you might imagine. In fact, the nearest one could be just a few thousand light years away. That's practically next door, on a galactic scale. In 2020, astronomers discovered a black hole in a system called HR 6819. It's hidden in plain sight, not roaring or glowing, but quietly orbiting with two stars. Invisible to the eye, but heavy enough to pull them gently in a dance. And then there's Gaia BH1, just 1,500 light-years away, the closest known black hole to Earth. It doesn't emit light, doesn't steal stars, doesn't make a sound. It's just there, a silent anchor in the dark. These local black holes aren't a threat, but their presence tells us something profound. The universe is filled with quiet giants, and we're not just looking into the far future of star death, we're surrounded by its past. They don't come for us. They don't chase. They simply remind us that the universe is older, deeper, and more intricately woven than we often remember during the daylight. Can time travel through a black hole? For centuries we've dreamed of time machines, of skipping ahead or jumping back, and black holes might be part of that answer, but not in the way Hollywood shows you. Time inside a black hole moves differently. For someone falling in, everything outside seems to speed up. Galaxies age. Stars are born and die. From their point of view, the universe accelerates. But from outside, the person falling in appears frozen, suspended at the edge, as if time stood still. It's a strange duality, two realities coexisting, both true, neither wrong. This leads to a question. Could black holes be natural time machines? Could we use them to travel into the far future? Theoretically, maybe. But practically, the trip would be one way. You could go forward, but never return. There's no safe way back out. No reverse gear once you cross the horizon. And yet the idea lingers. That time isn't a straight road, but a fabric, twisted and warped by gravity, especially here, where the rules quietly crumble. Do black holes have hair? It's an odd question, isn't it? But in physics, hair doesn't mean strands or fur, it means information. And for years, scientists believed black holes had none. They were bald, smooth, featureless. This was the no-hair theorem, the idea that once something falls into a black hole, only three things remain: its mass, its spin, and its charge. Everything else? Gone. Lost. But that left a paradox. Where did the details go? The shape of the object, the data it held, the uniqueness of its atoms? Physicists like Stephen Hawking wrestled with this mystery for decades. And now, there may be an answer. Recent theories suggest black holes do have soft hair, faint imprints of what they swallowed, woven into the quantum fields around them. Clues, whispers, remnants. So maybe black holes aren't bald after all. Maybe they carry history. They don't just eat, they remember. And their hair might be the universe's way of saying nothing is ever truly forgotten. The black hole that shouldn't exist. In 2019, astronomers found something puzzling. A black hole so massive in a place where none should be. It was called LB1, and it challenged everything we thought we knew about how black holes are born. You see, there's a limit. When massive stars collapse, they usually leave behind black holes up to about 20 times the mass of the Sun. But LB1 seemed to be more than double that, around 70 solar masses. How did it get so big? Did two black holes merge? Was it born from an unusual kind of star? Or was it something stranger, a completely different kind of object altogether? The discovery shook up theories, and more of these forbidden black holes are now appearing in data from telescopes all over the world. They're rewriting the cosmic rulebook. Sometimes what you think is settled isn't. And even in the most mysterious corners of physics, surprises still bloom, quietly, boldly, like a giant in the dark that no one expected to find. The gentle pull of the invisible. Black holes are often framed as terrifying, but maybe they're not. Maybe they're just gravity's final form, the quiet pull of the universe when all else has fallen away. They don't choose to destroy. They don't move to attack. They sit, still, patient, drawing things inward not with force, but with inevitability. They are not monsters. They are conclusions. And in that gentle pull, in the way light curves around them, how stars spin in their arms, how galaxies anchor to their weight, there's beauty, a calm kind of order, a silence that speaks more than noise ever could. So next time you hear the word black hole, don't think of panic or fear. Think of stillness, of time folding inward, of gravity humming its final peaceful song. In their darkness is a kind of grace, a reminder that even the most mysterious things in the universe obey the quiet laws of nature, softly, unshakably, always. The other side of a singularity. We often say a black hole ends in a singularity, a point where density becomes infinite and our math breaks down. But what does that really mean? What is on the other side? Truthfully, we don't know. And maybe that's the point. The singularity is where current physics waves the white flag. Space, time, and gravity all twist beyond our understanding. It's not a place. It's a question wearing a cloak. Some theories suggest the singularity is a bounce, not a wall, but a spring. That the matter collapsing inward might explode outward somewhere else. Perhaps as a new universe. Perhaps as a white hole. Perhaps as something we haven't imagined yet. Others believe the singularity is just a placeholder, a symptom of incomplete equations, that with a better theory, one that unites quantum mechanics and gravity, the singularity might disappear entirely, like fog in morning light. So what's on the other side? Maybe it's nothing, maybe it's everything, but right now it's a curtain, and behind it waits a deeper chapter in the story of existence. When light dances at the edge, just outside a black hole's event horizon is a region called the photon sphere. It's not a surface, but a ring, a place where light itself can orbit. Imagine a beam of light circling forever, never falling in, never breaking free, caught in perfect balance between forward motion and the pull of gravity, a ghostly racetrack of brightness, riding the rim of oblivion. This orbit isn't stable. One wrong nudge and the photon spirals in or out. But the idea that light, the fastest thing in the universe, can be trapped not by walls but by curves, is one of the most quietly haunting ideas in all of science. You can't see the photon sphere directly, but its presence shapes the glow around black holes. The bright ring in the famous image of M87's black hole? That's where the light lingered, bent into a circle by pure gravity. It's not just physics, it's poetry, that even at the edge of darkness, light keeps dancing. Could we farm energy from a black hole? Here's a twist of imagination that feels like science fiction, but might one day be real. What if black holes could power our future? The idea is this: as matter falls into a spinning black hole, it doesn't just vanish, it releases energy, tremendous energy, some of it in the form of radiation, some as jets of particles shooting out near light speed. Theorists have proposed ways to extract this energy. One involves throwing matter into just the right orbit and capturing the radiation as it spirals in. Another, called the Penrose process, suggests using the black hole's rotation to spin up machines outside its event horizon. It wouldn't be easy. It would take technology far beyond ours. But the math says it's possible. And in a distant future, if civilizations survive and grow wise, black holes could be used not as destroyers, but as engines. Clean, eternal, efficient. Imagine a Dyson sphere not around a star, but around a singularity, a harnessed darkness, lighting the way ahead. Do black holes help galaxies live longer? Black holes often seem destructive, but ironically, they might be helping galaxies survive, especially in their earliest days, when the universe was still young and hot. Supermassive black holes can control how stars form. When they feed, they unleash jets of energy that blast through surrounding gas. This might sound violent, and it is, but it also prevents that gas from collapsing into too many stars at once. Why is that helpful? Because if too many stars form too fast, the galaxy burns out early. But if black holes regulate that star birth, they help galaxies mature slowly, more gracefully, more sustainably. It's like a gardener pruning too many blooms. The act seems harsh, but it makes room for future blossoms. In this way, black holes aren't just cosmic vacuum cleaners, they're ecosystem managers. They limit, they temper, they shape. And in their silent guidance, galaxies don't just survive, they flourish. The sleep of the cosmos. What happens when the last star dies? When all the gas is used up, all the black holes have evaporated, and the universe is a cold sea of quiet particles? Physicists call this the heat death, a time so far in the future it's almost beyond thought. No light, no warmth, no motion, just entropy. A universe in perfect balance and perfect stillness. In that distant night, the black holes will be among the last to go, fading through Hawking radiation, whispering their last messages into a sky no one watches anymore. And when they're gone, the curtain falls. But maybe that's not the end. Maybe the universe is just sleeping, waiting for another fluctuation, another big bang, another breath in the lungs of time. Because even when all else fades, the laws remain. The structure, the possibility, the memory of what once was. And if the cosmos has a soul, then maybe it dreams too. Long before Earth had oceans, before the sun even flickered to life, black holes were already shaping the cosmos. Astronomers now believe that some of the first black holes formed just a few 100 million years after the Big Bang. They were forged from the collapse of the very first stars, giants made of pure hydrogen that burned hot and fast and died young. And somehow these early black holes grew rapidly. We don't fully understand how. Some must have swallowed gas at incredible rates. Others may have merged, and their growth helped seed the first galaxies. Now, across space, we see their shadows in ancient quasars, brilliant lighthouses powered by black holes from when the universe was still a child. These are not just relics, they're records, living fossils of the first era of creation. When we gaze into deep space, we're not just looking far away, we're looking backward and hearing the first echoes of gravity's deepest call. Let's stretch the mind even further. What if our universe isn't the only one? And what if black holes are the bridges between them? Some theories suggest that when a black hole forms, it doesn't just compress matter, it creates a tunnel, a one-way door. And on the other side of that tunnel is a new universe, expanding just like ours did after the Big Bang. Imagine, every black hole could be a seed, a sprout, a cradle for another cosmos, hidden behind an event horizon. Infinite branches on the tree of reality, a multiverse, blooming from collapse. Of course, we can't test this yet. We have no way of peering through the veil, but the math allows for it. And when the equations hint at something so vast, so elegant, it's hard not to wonder, maybe our universe was born this way too, not from nothing, but from the heart of a black hole, in someone else's sky. Right now, we study black holes from afar, through X-rays, gravitational waves, and shadows on distant skies. But what about the future? Could we ever go closer? New telescopes are coming, ones that will let us see black holes in finer detail, hear their vibrations more clearly, and even map the space around their edges. We might send probes someday, robotic explorers that could skim near the event horizon, transmitting data until their last breath of signal. We may even build gravitational observatories in space, arms millions of kilometers long, listening to the universe's deepest notes. And far, far ahead, if humans endure, we might harness the power of black holes themselves, for travel, for energy, for answers. Because exploring a black hole isn't just about understanding it, it's about understanding everything that bends, flows, or breathes beneath the stars. Black holes aren't mistakes. They're not interruptions. They're part of the plan, written into the language of physics like commas in a poem. They recycle matter. They help galaxies grow. They store energy, regulate heat, and stabilize star systems. Without them, the cosmos would unravel, not with a bang, but with a slow, lopsided drift. Their gravity sculpts beauty. Their silence inspires questions. Their very presence tells us there's more going on than what we see, more beneath the surface, more beyond the light. So often humans fear what they don't understand. But when we study black holes, we begin to see the opposite. The unknown isn't something to fear, it's something to follow. And in the quiet heart of every galaxy, a black hole waits, not as a threat but as an anchor, the still point in a turning world. Here's a soft thought to close the night. Everything you are, your breath, your bones, your mind, is made of atoms that were once inside stars. Those stars were shaped by galaxies, and those galaxies were held together by black holes. But not everything fell in. Not everything was devoured. Some matter escaped, some floated free, and over billions of years those particles drifted, cooled, collided, and formed you. You are the light that didn't fall, the echo that slipped past gravity's grasp, the story that kept moving outward. You are the leftover of a million moments that nearly vanished. So next time you look at the stars or hear the word black hole, remember, you are not separate from them. You are part of them, a chapter in the same quiet book, and maybe, just maybe, the universe made black holes not to erase, but to remind that what stays is just as precious as what goes, why darkness isn't empty. When we look into the night sky, we often see black, an endless void, but that darkness isn't empty, it's full, brimming, alive with things we can't see, photons from distant galaxies, invisible particles zipping through your body, radiation from the beginning of time, dust, gas, gravity, and space itself, all quietly stretching in every direction. Even the darkest space between stars hums with potential, with quantum energy, with virtual particles flickering in and out of being. Darkness, it turns out, is not the absence of light. It's the canvas that holds it. So if you ever feel small in the face of it, remember, even the space that seems empty is whispering, always moving, always being, and in that stillness you are held, not lost. The long goodbye of a black hole. Imagine the final breath of a black hole. After eons of silence, it begins to fade, slowly losing mass, its horizon shrinking, its gravity softening. It's not loud, not violent, just quiet. It radiates, gently, patiently, until one day there's almost nothing left, just a faint glow then, gone. A lightless kiss released into the dark, the ultimate goodbye. No drama, no fireworks, just the last note of a long song. Some say that's when the information is released, the memories once hidden within, finally let go. And that idea, that even the most hidden truths return in the end, is a comfort. That all endings, no matter how long delayed, come with a kind of peace. It's not death, it's closure, cosmic and complete. You'll never truly be lost in the universe. There may be moments when you feel forgotten, like a dust speck on a dust speck, a breath inside infinity. But the truth is, the universe never loses track of you. Every atom in your body obeys its laws. Every heartbeat sends ripples into space. Every thought, every laugh, every tear, all of it bends gravity, nudges photons, stirs the ether. You exist, fully, and the cosmos knows it. You are encoded into its motion. You're part of the same equation that governs galaxies, black holes, and the stretch of space-time itself. You are not a visitor here. You are not separate from this place. You are this place, this dust, this light, this moment, and just like light from stars, you go on, always. The soft paradox of being small and infinite. You are tiny. Your entire life fits on a single mote of dust in an ocean of stars. And yet, your mind can hold galaxies. You can imagine the edge of the universe. You can feel the gravity of a black hole from billions of light years away. That's the paradox. You are a speck, with the capacity to understand the whole. You live for decades, yet think in billions of years. You sleep each night, while gravity folds space behind your dreams. And so maybe being small isn't a limit. Maybe it's a gift, a way to feel the infinite in a body that still needs to rest, to cry, to love, to breathe. Because that is where meaning lives, not just in the stars, but in the quiet between them. When you sleep, the universe keeps spinning. And now, as your eyes begin to close, let this final thought carry you gently into sleep. The stars will keep shining. The earth will keep turning. Somewhere a black hole will still hum, and light will still bend around its edge. You don't need to hold it all. You don't need to understand it all. You only need to be, to rest, to know you are a part of this great, mysterious, soft-moving machine. Even as you drift off, the atoms in your body still obey cosmic law. Your dreams still ripple through space. You sleep, but the universe sings on, And in that music, you are always welcome, always known, always safe.